All right, so just to try to bring some closure to this, and I'll make sure that you guys are comfortable with what you did. You, as I showed in number one, have options. If you decide to do the first row and the second column, you could create a little equation. Not that you have to show all this, but your little equation would multiply -3 times y and then 0 times 4. But that would have to equal the corresponding number. And if you did that row and column, you would get that equation so that y equals 7. And then we can kind of do the same thing with x. All right. It does come out to be x equals 2. And again, there's so many options. I'm just picking something here. I see some x's. It turns out that there's x's in both of those. But if you would choose the second row in the first column, you have to set it equal to the number in the second row first column. Okay, but you get yourself some 5x's equaling 30, which is, oh, did I say x equals 2? X equals 3. X equals 3. Is there anything else with number 1? Again, there are other ways to come up with those values. So, Julia, can you kind of give a paraphrase here?
So yesterday when we did the inverse matrices, we said that the equation would be like the inverse of A is 1 over the determinant times the D negative D negative A. So I found the determinant first.
All right. So the determinant comes out to be x.
So then I switched those numbers around inside the absolute value signs. So then that would be the D negative CA.
Good. So you switch the position. I'm just saying this for the sake of people at home. You switch the position. You switch the signs.
And then I put B at the end, and I multiplied 1 over x times -3 because that's easier.
Good.
And then to make it equal to -1.5.
Okay, and of course that's this equation we're looking at, and then you go on your way solving that with some good algebra. It's good. So again, we found the inverse and basically set a corresponding number equal. Okay, it does come out to be x equals 2. What's this, Brandon? It's also very good.
Well, yesterday, anything times its inverse we can equal to 1, 0, 0, 1. So I pretty much just once I had that, I pretty much did the same thing in problem 1, where you multiply them and then get an equation 1.5 or -1.5x plus 3 equals 0, and just solve for x. I just searched the 1.5 or -1.5x plus 3 because that seems easier than the square roots.
Yeah, good. You picked this one. Am I saying this right? Okay. Question. Maybe I'm missing something, but help me out. What happened to the determinant?
I didn't.
Okay. I didn't notice that when I called upon you, but it's all right. We can still kind of figure out. I feel like, oh, no, you're good. I'm getting myself kind of confused over here. You didn't actually find the inverse. You just used the two equations, right? Or the two matrices.
Yeah.
Yeah.
Yeah, because on the paper it said if the inverse of A equals B. So yeah.
Good. Thanks for setting me straight so you don't have to do that. All right, so being willing to work with the formulas and let x kind of work itself out. So number 3, did you catch the little piece to the, again, the lesson yesterday? What does it take for an inverse to not exist? What does it take for an inverse to not exist? It means the determinant would equal 0. So it's just a little determinant problem. And I want to make sure that I didn't confuse anybody. I kind of confused myself, but when you do the determinant, it's always the primary diagonal. That would be -14 minus the secondary diagonal. It has to be in that order. So minus negative 3x. Again, it's the primary minus the secondary. And trust it, it comes out to be a decimal. It's no big deal. You're going to end up with you're actually going to end up with a positive 14/3, or the decimal equivalent. Okay, but it's basically a little determinant question. Now, there's going to be an assignment full of all kinds of these. I will get it on your desk here in a few moments, but I want to have a little calculator conversation with you. The calculator conversation is actually to show you that the calculator can do matrices. Yes, there's actually a matrix button. There's a matrix menu. And this isn't just kind of fluff. This is actually a skill that I want you to have. I also want you to be careful, as I always say, that you don't get too excited as if the calculator suddenly will do all the math. As you'll discover, the calculator can't do the X and Y problems, but we can use the calculator at the right time to be able to deal with some numbers. So, do you see the matrix button? Sometimes, just like the comma that some of you asked me about, if you've never looked for it, it's like, where is it? It's usually on the left side of the keypad near the top. For many of you, it's second. You have to hit the second button, and you get to the matrix menu. Okay, now in the matrix menu, you may or may not have some matrices in there. It depends on if you're using a calculator that your brother or sister used or a school calculator. Anyway, it doesn't matter if you have stuff in the second column. You're just going to type over top of it anyway. Okay, so the main thing with navigating this menu is that you actually have to scroll over to edit. For some reason, they actually put that at the end, but you scroll over to edit so that you could type in some matrices. So here's a matrix A and a matrix B that you can kind of mess around with. If you scroll over to edit and then hit enter, you're going to be editing matrix A. And then it's probably kind of intuitive here. You're just going to change the size of it. I like using the enter button. The enter button, rather than the arrow keys, is recommended because when you hit enter, it'll actually insert the numbers. It'll change their values. Once you type matrix A, you actually have to, this is kind of the weird thing, there's no back button. This isn't an internet browser. So I can't hit the back button and go back one screen. You have to hit the matrix button again. Hit the matrix button again, slide over to edit, slide down to matrix B. Make sure you slide over to edit, but then slide down to matrix B. And once again, go to town, changing the parameters of that matrix. Does anybody have any concerns just with getting some numbers inputted in there? Or are you done with that? Now, I thought we would, learn a few things about the calculator, but also think a little bit about the commutative property. If you're like, what do you mean a commutative property? Probably back on the first day of algebra, you talked about the commutative property. That means you can change the order. You can change the order. So what if we do A times B? The order of A times B. Well, I want to show you how to do a multiplication problem. Whenever you do operations on this calculator, you always do them on the home screen. If you're doing 2 plus 2, you do it on the home screen. If you're doing A times B, you do it on the home screen. What I'm getting at is that you have to hit the quit button. You have to hit quit and get your cursor back to the place where you do calculations and operations. Are you with me? So we go back to the home screen, and then we actually go back to the matrix menu so that we can grab these names A times B. You have to hit the matrix button a couple times, and you basically get AB, and bada bing, it multiplies. Remember, to multiply, it's doing row times column. Obviously, it just does it really quickly. So, commutative property, like what I'm sort of getting at here is, what if we try to change the order? What if we change the order and we try to do ba? Just giving you a chance to kind of fool around with the buttons. You got to hit the matrix button, grab B, grab A. Ba is nah, you can't do it. Okay, now you do get a dimensional mismatch. Dimensional mismatch means what we talked about. Remember, the numbers have to match up. So if we change the order, now 3 and 2 not matching up. Okay, we actually kind of talked about this a little bit in class. You can't change the order of a multiplication problem necessarily. For one thing, sometimes you can't even do it. Okay, let me show you a couple other little buttons here. Probably not surprised that the calculator can do a determinant and an inverse. I think that's the same matrix A. Always double check. 7532, yeah, it's the same matrix A. What about the determinant? Now, just saying, we should be able to do that sort of in our head, right? The determinant is going to be 14 minus 15. Okay, so pretty easy math, but how about letting the calculator do the determinant? Go back to the home screen. If you're not there, go back to the home screen. Now select matrix, and in the middle menu is the math menu. And I'm sure you can see the determinant as the first choice. Now you have to do the determinant of A, so we have to go back and grab the symbol A. So we're going to do DET of A. All right, and not a surprise, we get -1, as we knew it was 14 minus 15. Imagine, though, doing the determinant of like a big old 4x4 matrix. Okay, it would make quick work. Okay, but that's not as much fun as trying to do it by hand, but the calculator could do it. And how about an inverse? Let's talk about an inverse. Now, this time there is no inverse symbol in a special menu. So following here, you just need to get the symbol A, and the inverse symbol, it's really more of an inverse operation, is on your keyboard. It's actually the fourth key down on the left side. It's x to the -1. Fourth key down on the left side, x to the -1. That stands for inverse. So I do a to the -1 or a inverse. Now, it depends on how fast you're at mental math, but it did the whole inverse. It did 1 over the determinant, it switched the numbers, and it multiplied it back in. So please know that that would be the full final answer using the full rule. We didn't talk about doing an inverse of like a 3x3 or 4x4 by hand. That's beyond the scope of this class. There's a course in college called linear algebra where all you do is talk about matrices. So there's more to it than what I'm showing you, but if we needed to do the inverse of a large matrix, we could use the inverse button, which we will. Now, oh, I forgot my little thinker Bob guy here. Did I mention in the video? I think I did, but you actually can find the area of a triangle go figure with matrices. It's like, hey, the area of a triangle with matrices. Okay, now this might be something you want to jot down if you haven't jotted anything down. You're going to use this a little bit like on the assignment, and you also might use it for some other things throughout this chapter. But I'm going to end up giving you a little formula, but maybe you want to sketch this triangle just so you understand that it's the vertices given as ordered pairs that enable us to find the area. So we have 3 vertices, obviously, given by ordered pairs. Just by the way, it doesn't matter which point is considered the first, the second, and the third. It doesn't matter. They're just 3 points. Okay, now it turns out that basically a 3 by 3 determinant with a little bit of spice mixed in and maybe a little bit of sugar and spice is going to give you the area. Here's the sugar and spice. The area of a triangle will be considered 1/2 of this determinant. Make sure you kind of realize what the screen's showing you, 1/2 of this determinant. The determinant has 3 rows. Each row contains the vertices. As I hope you can see, the last column seems to be filled with the number 1, which it's always that way. So we basically take the 3 points, throw them into a matrix. The last column is filled with the number 1, and we do 1/2 of that determinant. Now, I think you guys know I don't like to be a kind of teacher. It's just like, hey, kids, here's some other math fun. We like to kind of prove things or have a good idea or some idea. I'll be honest with you, I never have sort of proven this or been able to kind of break through the code. I sort of wonder if you did the determinant as an expansion, what you might see. Okay, you would see 3 mini matrices. Again, I kind of wonder those 3 mini matrices, how they could connect to an area. And I'm simply trying to maybe encourage you to dig a little deeper if you want to. I did have one student, Anthony Migash, get pretty close to kind of showing me the purpose of this, but sometimes you really have to have that desire. And again, if you don't have desire, it's fine. I'm admitting to you, I never did it either. But there's got to be some math behind this, at least sort of more like a reason. All right, let's do a problem. Here's a triangle. If you want to jot it down, you can. If you want to just fire up your calculator. But I'm kind of wondering, can you do the little sugar and spice formula? Now, I kind of wonder, is there somebody out in the crowd that put their numbers in a different order? I would imagine if every student put it in the same order that I did, that's kind of strange. So it doesn't matter what order you put them in, as long as it's X, Y, and then 1. What does matter is that you do the determinant. So we're certainly implying that you're going to use the matrix button to do the determinant. You could do the determinant with an expansion. By the way, you will do an expansion for a grade sometime. So a 3 by 3 expansion. But we can use the calculator button here. Okay, now, how'd I do when you put the numbers in? You either get 36 or negative 36. Now, if you didn't get negative 36, it's fine. But I do want you to realize that's why there's a plus or minus in front of that formula, because we're never going to get a negative area. So, yeah, you divide it by 2 or by negative 2. In other words, the area is always positive. That's what the plus or minus was all about. So again, the final answer is 18.